Hey guys, so today we're going to have a little look at how a thermistor works in this video. Now I've got you a display up here, which is a virtual setup of how a thermistor works. So we can see that there's a pool of water here, a beaker of water with a Bunsen burner underneath it. Then we've got a thermometer in it, which is reading 0 degrees Celsius. This orange little blob here is the thermistor. It is and remember, a thermistor is a resistor, it's a device that's resistance changes depending on the temperature. So we're going to look at what would happen if we altered that temperature. So let's start off with 0 degrees Celsius. So what we can do using this really handy little tool is that we can just say, okay, so what would the thermistor be if the water was at 0 degrees C? So if it was nearly frozen, or it was on the point of the border of freezing anyway. So we click plot point here. Okay, so we find out that, well, this little ohm meter tells us that it's 9.93 kilo ohms. So 9.93 thousand ohms, nearly 10 on the graph here. So what's going to happen if we increase the temperature by 10 degrees? So we've used our Bunsen, we've heated it up a little bit. Let's see if we increase it by 10. Okay, so if we increase the temperature a little bit, the resistance decreases with the thermometer. Now let's see if that continues, because we need to check that our trend is correct. We're heating the water up to 20 degrees Celsius. Brilliant. We're now at 20 degrees Celsius, and it's reduced again. So we can see that there's a trend going on here. As we increase the temperature, the resistance of the thermistor will decrease. Let's see what happens again. Let's go up to 30 degrees Celsius. What have we got now? And we're seeing that the resistance is decreasing. It's starting to curve off now. It's not quite as reduced as much as it did before, but it's still reducing. Resistance is still reducing. Let's go up to 40 degrees Celsius and have a look. Plotting our point. Okay, so we're seeing again a reduction in resistance. So I think we can be pretty sure now that a thermistor, when you increase the temperature, the resistance will decrease. But because it looks good, let's continue up every 10 degrees. And we see that the resistance is still decreasing as we increase the temperature. But what we're actually getting here is we're starting to see a curve, aren't we? Well, ish, where the resistance is decreasing less each time. Up to 80 degrees Celsius. And again, we've still got that reduction. We're down to nearly, well, just slightly less than 1 kilo ohm, so 1,000 ohms of resistance. And then we're up to, and then 90 degrees Celsius. Okay, so what we're seeing there is that the thermistor is not working. It has reached its almost, well, slightly, it changes slightly at this temperature here. It's reaching nearly its minimum resistance. And then we've got 100 degrees Celsius. So we can see that the overall trend that we've got here is that the resistance is decreasing as we increase the temperature. What we can do here is we can use this to repeat the reading. So it shows that it's not always spot on. So that shows us a slightly better result there. So what we've done is we've repeated the reading to make sure to check, because you can see it can be, when it's this hot, it's not completely accurate. So it shows that it can change slightly, gives us a little bit of inaccuracy in our readings, which doesn't come from us. So it's not a human error that we've made by looking at this and seeing that it's just given us the wrong answers, that our reading was wrong. It shows that there is error in the system.